Okay, next we have Optiwave, a company that's been around since 1994. That's 26 years in the business, and that's something that we've seen through this whole showcase this week. Companies that have longevity. It's really nice to see the family come together that way. So this is a company that does software, design, simulation, optimization software spanning components all the way to systems and networks. So Dr. Ahmad Atiye is the Vice President of Optical Systems. He has over 100 publications, 25 patents. He's also an adjunct professor at University of Ottawa. Optiwave is a Canadian-based company again. So welcome. He's going to be talking about their Optilnstrument software. So Ahmad, please go ahead.
Thank you. Thanks, Tom. Thanks to Jose, and hello everyone for this hour where we are going to present in our time slot here a new product which Optiwave has introduced into the market about a month ago. And this product, which is a software, enable users to communicate and control instruments remotely or physically co-located. This is a quick introduction about Optiwave. It's established in 1994. It's located in Ottawa, Ontario, Canada. And mainly Optiwave design and software and simulation tools to optimize the capabilities for designing components, links, systems, and networks. With this software capabilities, users can shorten their product line introduction. They can improve their product quality through simulations and improve the productivity and cost effectiveness. Quickly here, just to mention that Optiwave licensed the different products for over than 1,000 industry-leading companies, universities, research institutions, in over than 75 countries. And this is a list of some of the product industries or universities and users of Optiwave softwares packages. Here we're going to introduce the different software packages, which is categorized into system and subsystem levels and component levels. In the subsystem levels, we offer two software, which is one of them is the OptiSystem software, and the other one is OptiSpice, which is an optoelectronics software capable of designing optical and electronics components. And the other software packages also in designing component levels, which is OptiPPM and OptiFDDT, OptiFiber, and OptiGraping. So this is the legacy product, which has been in the market for a long time. As I mentioned recently, we introduced this software, which is called OptiInstrument, to communicate and control instruments. And this is mainly the talk today. If you go to Optiwave website, you should be able to download a 30 days free trial for evaluating the different packages of the software. What you need to go, once you go there, you go downloads and then 30 days evaluation. You need to register on the website. And once you register, basically you go into your account and download the either of these software packages I mentioned. Now, once you download the software will be stored automatically under the C drive in the program files under Optiwave software. You're going to have different directories here. That one directory which has the drivers and the executable file, and the other directories which have the documentation, and that could be example libraries and so on. So in general, once you download the software, this is the look of the graphical user interface, which has the file. Typically, the default GUI has Optiwave here title, while if you have a saved file, you can have your file name here and then the software name here. You have different windows here where these windows are dockable and resizable. You can resize them. You have each one of these windows has its own functionality. We're going to have after at 12 o'clock a breakout room where we're going to do a live demonstration and show you the whole GUI with control of different instruments, and show you how is each of these windows is operating and how you can use it. Mainly, you can have here, as you see, one of these, if you click on of these items here, you're gonna have SCIBI commands window where you can load your SCIBI commands, and then you can test the SCIBI commands and then check the communication with the instrument. So all of that we're gonna demonstrate it through the breakout room today. So I'm gonna generally talk about the features of Optilnstrument software. You're gonna see that the software, once you start working on it, it's very user-friendly, very easy to use, simple to communicate with the equipment and control it. So you would be able to execute the communication protocols. Usually we use SCIBI commands here, so you can execute a single command or execute a sequence of commands to control the instrument, to set up parameters of the instrument. Now, usually SCIBI commands, it can be placed in a PDF file provided by the instrument manufacturer, or we try our best to communicate with vendors and create XML files which has the SCIBI commands and the description of these SCIBI commands. Then eventually what you do is you can load your SCIBI command file into the GUI, and then from there you can, from a tree control, you can extract any command you wanted and create a sequence and then execute the sequence. This is something, again, we're gonna demonstrate during the breakout room 1 hour later on today. Another thing is of the this software capability is you can generate Python script for any command, SCIBI commands, either single command or a sequence of commands. And once you generate this Python script, you can run the script as Python or in a Python environment, or actually in the GUI itself, because the GUI has a Python editor built in, so you can run Python scripts in it. Also, the GUI has its built-in signal viewer and this a CSV file analysis page. So if your equipment has a visualization capability, you can remotely log onto the equipment. You can view the signal, download them into the GUI, and then process the signal there in the GUI. Also, you have the capability, as I mentioned, to remotely communicate with the equipment through internet or through any communication means you have. Now, the windows are deckables and resizable, so you can play around with the GUI. Okay, so the applications of Optilnstrument software, as I mentioned, and emphasizing on it, you can remotely communicate with the equipment, and you can, or you can connect directly through a USB, through a serial port, and you can set up parameters there and change these parameters. You can do automatic testing, so and characterization. So, for example, in manufacturing floor, if you have, let's say, for example, you want to test transceivers or test modules, you can set up the SCIBI commands and then run the equipments automatically, and let's say, for example, do stability testing or characterization or whatever you're gonna do. You can do long-term stability, as I mentioned, and also you can, because of the capabilities of the viewer, you can display the generated signals. You can extract these signals, you can save them and process them in the externally or inside the GUI. Optilnstrument also allows users to integrate the equipment into other software packages, for example, systems packages where you can do simulation. So you can extract data from the equipment, load it into a simulation tool, and then you do your simulation in another environment. So this is another feature of this software. Okay, so in terms of displaying the waveforms I mentioned, you can have as you can see here, there's a function generator, there is an oscilloscope, and there's the signals which is generated by the function generator is displayed over the viewer here. You can manipulate the picture, the image here. You have an editors built in. You can zoom, you can have analysis on the image. You can save the image in the different formats, as well as you can extract also the data. And the data you can copy it and save it into CSV file. You can do graphing and so on it. The captured waveform, as I mentioned, can be processed and saved. Now, this is a general view of the GUI, which is in action. Here shows you, for example, the tree, control tree, which has the SCIBI commands. These SCIBI commands, you can drag them into a single window here, where you can test a single command. As you can see, this is identification, and there is here a window which you can show that the command is successfully executed. Then the command, if you are happy with it, you drag it into another window here where you can create a sequence of command, and then you can run the sequence of command to operate certain functionality which you like to do. And during the process, you have a bar here where you can, in this bar toolbar, give you the progress of executing these commands. The commands can be saved. You can save the commands, and you can load the commands again if you want. You can save the results of the execution of these commands. And there is also, we offer parsing software. We can extract the necessary results which you require from the sequence of command as well. This window, as I show here, this is data from the wave formats, and you can switch between the data and between the graph. Okay. Now, the saving process here, you can, as I mentioned, you can save a sequence of command, and also you can save, and you can use the file save here. You can save any documents. For example, one of the tabs here, if you click on it, you open this window, which is a document window. In the document window, typically you can place any kind of file you want in any format you like, and then you can save it as well. So what you have at the end of the day is a file saved with all your sequence of command, where all documents which you like to have related to that, for example, project you are running, and then you can load it or pass it to any one later on. The Python scripting here give more details on it. It's the Python, you can create a Python script for one command or a sequence of command, and you can run these commands through the GUI itself, the Python script editor inside the GUI, or you can run it externally using a command prompt or Windows PowerShell. You can load your own Python script into the GUI and run it from the GUI as well. This is an example of a GUI of a Python script which is generated, and for a sequence of commands. One thing which we need to emphasize on here is in setting, we're going to demonstrate it later on today, also is the commands we allow you to place timeout to allow the commands to be executed. So this is very important when you do the control of equipment, to make sure that you have the proper delay to allow the execution of the commands correctly. Okay, and next here, just quickly talk about the example library, which is once you do the download, you have these examples from two companies at this moment, because as I mentioned, we are just recently released this product. We communicated with on partnership with Expo to add up their equipment into Optilnstrument here, and another company which is Rigol. So we have different examples. You can access these examples if you have these equipments. Mainly with the Expo right now, we integrated the LTB8 platform, which has different cards, which have lasers, switches, power meters, optical spectrum analyzer, as well as a transceiver card, which you can test the transceivers with it. And this is part of the demonstration. We're going to show you today the different cards in operation from Rigol or from Expo. And now I'm going to take this opportunity to communicate with any vendor of instrument vendors who are interested in collaborating with Optiwave to include their equipment into Optilnstrument. What we can do, we can arrange with them to get the XML files, which has the SCIBI commands for that instrument, and then we create this XML file into the library of Optilnstruments, and then allow the users to have it as an example in Optilnstrument. The demo today is going to be in the 1 hour after this presentation. Would be talking about the platform from Expo, where we have different cards for lasers, CW lasers, switch, attenuator, and OSA, and then we can control the operation of these lasers. And then we generate Python script. We run Python script to run also a transceiver testing, and we do parsing for the Python results. This Python script to run the results of the execution of the generated Python, and then show you some examples about Regal equipment, how they operate, and how is the display of the signals and the data analysis and saving. At the end here, just wanted to highlight that if you wanted to contact us for at any time, please either use the support@Optiwave or my email address here. And I'd like to thank everyone attended today, and also thanks to OSA for this opportunity to give us to introduce our product. Thanks again, and we are open for any question.
Yeah, thanks, Ahmad. And I just wanted to go back. So you said this has been a product for a couple months. It's been in development for how long then? It's
about 9 months development time, actually. So it's very recent. That's why we don't have many vendors at this time, equipment vendors included in the library. So we are in process, hopefully, to integrate more equipment and more vendors into our library here.
Yeah, and I want to also repeat the point that you said you'll be doing a demonstration in the breakout sessions. Could you just say a word again, or I mentioned it, but about the things that Optiwave does? So design, simulation, optimization from components to systems and networks. Can you just kind of elaborate on that just for a moment? A lot of people may not be that familiar with Optiwave's suite.
Thanks for the question. Yeah, and I think it's the software packages which we have, like OptiSystem, it allows users to simulate any system from end to end, like including everything from the lasers, modulators, multiplexers, fiber, amplifiers, dispersion compensator modules, receivers, DSP, as well as we have a huge library for visualization. So every equipment in the market, almost, we have a component in OptiSystem to view the results, use it. For example, from constellation diagram, oscilloscope, spectrum analyzers, and we address all the modulation schemes for coherent modulations, QAM, and also, like, for example, PAM modulations, null return to zero, dual binary pulses, all of this, everything almost the market needs in the transmission, optical transmission systems, is we address it into the OptiSystem. And OptiSpice is a kind of combined electronics and systems. So we add up the electronics into this simulation tool. So you have, for example, you can have your driver circuitry for lasers or for detectors, for the modulators. And we also integrate our software with other developer like Mentor Graphic, Cadence. We are integrating this OptiSpice into it. So we allow users to make photonic integrated circuits, actually. And the other software is like OptiFDDT, OptiBBM, OptiMode. This is for designing waveguides or materials to study the materials, the effects of the materials on the mode propagations and all these things. Beside that, the fiber itself design and integrating design, we have two softwares to address them. So you can design your own fiber. You take the parameters from the fiber, implement it into OptiSystem. So it's a cohesive kind of product line to address the needs of the users in the market.
Great. Yeah, that's good. So, well, I'll tell you what, I think we need to move on to the third segment of the hour. So thank you, Ahmad. And a reminder that your further questions and the demo will happen at the end of this hour in the breakout sessions in the networking part. So thanks again, Ahmad.
Thank you very much.